Okay, good evening, guys. Welcome to ML Ticket. We are at the middle of a ongoing project, and today is the fourth day, I guess. And so we should get going with our project. And let me just present my screen. Okay, hope you guys can see. So yesterday we talked a lot about sampling techniques and stratified sampling, why we are using stratified sampling and all. Okay, and we took the data and divided into training set and testing set. And I said specifically yesterday that we are only going to work with the training set. That's why I copied the training set into a variable, and we are going to use this variable throughout our entire project, because we are not going to mess with the original training set. We are going to make a copy and then do whatever we want with the data set. Okay, because it's a kind of safe. So today we have a lot to do. Okay, so let's get started, and we have a lot of visuals today, of course. So brace along. Now, have you ever wondered, from the beginning of the project, have you ever wondered that why our dataset contains this longitude and latitude? That why exactly our dataset actually have this longitude and latitude? Because up to this point, we have not talked about this longitude and latitude much. And I have told you, Jay, these things doesn't even matter at some point or the other. So why do we actually have them in our dataset? You can just say, Jay, we can just get rid of those two columns, right? And we can still work fine. I would say, yeah, you can work. You can work fine, but let me show you the magic. Why I have chosen the data set. So I'm going to graphically plot a graph and graphically plot a graph, and it will be a scatter plot. For all those of you who don't know what is a scatter plot, you will just understand in a moment. So I am choosing the x-axis as longitude. Let's see if I can spell this correctly. Okay, fingers crossed. Okay, acha, wait, I need to do a figure size. Yeah, oh, that's too big. Okay, so this is a scatter plot. As you can see dots. Okay, so a scatter plot, it provides a dot at the point where the data is present. So I have chosen the x-axis as longitude and the y-axis as latitude. Now you can see that there is a certain kind of shape that is forming. And another observation that you can make, okay, there are some data points. Let me just pull up my Epic Pen tool. Okay, so okay, if you can see that there are some points like this. Oh, this is a bad color. Okay, yeah, like this point, this area. These are that the dots are overlapped over each other that we can't even separate those dots. They are like completely identical, overlapped with each other, and it's forming a plane right now. But in actual, these are actually a single dot. Okay, so these are very important observations that we are starting to make. So what is this thing? So this come the first observation that you should make from this overlapping thing, that there are too many data points in this secluded area, and this area and this area contain more data points than maybe this area, okay, than this area. Okay, so we have an idea that, okay, so these areas contains more data points, it should mean something. Okay, so this is the first observation that you make. So let's continue, and let's see what happens. So I am going to enhance this stuff, and just keep in mind that it will start forming a shape. So let me just copy the same line, and just I'll add a few more parameters that can help us. Now look at it, Jay, when the data points are overlapping, okay, when the data points are overlapping, you can use another attribute known as alpha. Alpha, as it says, uses the backend specifier, okay, or makes plots in the series of data frame. And this is why I love actually this is why I love Colab actually. Okay, so what does this alpha do? Let me just show you, and you will understand right away. I don't need to explain. Okay, that's too much, I would say. Yeah, this is good. So you can see what this alpha does. This alpha does is it makes the dots a little bit transparent. So I am using a zero point 0.4 that is 40% transparent. So the data which are overlapping are more visible, because if you place two 40% transparent over one another, it will form something less transparent, I guess, a little opaque. So still you can understand that this area and this area is evidently have more data points than it. So these are the areas that we should be concerned about. Oh, what is the observation that we can make from this? Okay, still I'm not getting it, what observation is actually that I need to make from this. So let's explore a little bit more, then maybe we can understand. So let's continue. Okay, so I'm going to copy the same line. It is very useful to copy your code and reuse it, because sometimes it helps. Okay, so let me write a little bit more code. This will be a long line. Don't worry, I'm just gonna, after I write this line, I'm gonna post it on the a box. So don't you worry. Let us take another parameter. We can as we know that in a graph we can only take two parameters, right? X-axis and y-axis. But in here, not only we are working with graph, we are also working with data, and this is machine learning and visualization. So we can do many more stuff. So I am going to add another parameter, and I'm going to add the population parameter. Remember the population parameter that we have. So I'm going to add that population parameter. I'm going to explain the whole code again, so don't worry, don't be terrified. And not only the population parameter, I'll be also adding, let me remember, I think it was median house value. You know, the final value that we need to be, that needs to be predicted. Fingers crossed. Okay, This is a good theme. Before you look at it, I want you to search something on the web. I want to search California and go to images. Okay, California map. Okay, let's see what we can look at it. Maybe this is good enough. Look at the map of California. Let me get a good map. California. Let's see we can if we can get a good map. Yeah, this one. Look at it. It's a map of California. Okay. So these are the data. This is the actual map of California. And now, if you look at it, this has a great resemblance with this. So it is actually the map of California only. We are looking at the map of California, and this is the reason I have used, when I have taken this data set, which contains the latitude and longitude, and this is why I have not deleted those columns. It actually generates a great visual. Okay, the transparency is 0.4. I guess I can increase the transparency a little bit so that you have a clear picture. Okay, this looks good. Okay, so let's go through the code once. Let me just mm, copy this and paste this over here. Okay, so you can just copy this thing, and I'll just explain the code one more time so that you have a clear understanding. So we are plotting the data, which is a kind of a scatter plot. I am taking the x-axis as longitude, y-axis as latitude. Figure size is nothing to be concerned about, and I am considering a transparency of 50%. S is another parameter that we can use in scatter plots, and it is like this thing. Acha, I'm just going to explain a little bit later. Just look at it. Just consider the housing population is another data point that we are considering. C takes another, the C attribute takes another parameter, and cmap.plt. This whole thing is nothing great, but I'm just using a style. That's why. So just let me tell you what this S and C does. S, look at it. If you look closely at it, you can see that some of the circles are bigger and some of the circles are smaller. Bigger circles represent more population. Smaller circles represent less population. That's why. That is why I have used that S. So if you see a very big circle, then you can say that it has more population. If it is a small circle, it has less population. And C is the median house value, I mean the values of the house. Now if you can look at the map, you can see that this side, this sorry, this side is ocean. Okay, so it is clear from here that this side is ocean. So this particular side, sorry, this particular side is the ocean side. Okay, so now look at it. Now you have a great picture in front of you that you need to understand. This is the one of the most greatest picture that you will see in this particular project, and it is very colorful, I would say, and it is at least colorful to me. On the right you can see a color bar. Okay, it tends from 1 lakh, no sorry, 1 lakh to 5 lakh. Okay, and it increases. As it increases, it changes its color. So the more the value of the house, the more tendency is that it is a sea house, sea facing house. If you can look at it, all the houses which have more median house value, or the price of the house is more, those houses are actually sea facing houses, right? All of these houses are sea facing houses. As we go inside or we go inland, the median house value decreases. That's why if you can look at here, if you look here, you can see it is below 1 lakh. But if you look here, it's like the most expensive house on the in California, I guess. So this is a very good observation that you need to make, that needs to be understood as you go. And another thing that I would like you to understand, if you can just zoom in a little bit, if you can zoom in a little bit, you will see that those red circles are very small circles. They do not represent, do not they are not very big circles. What does it represent? It represents, Jade, the number of rich people, the population of number of rich people are not that great. But if you can look to the inward side, you can see a lot of large circles. So the most of the people living in California are middle class. We have also seen this thing in the previous way, where we have shown that the average median income ranges between 2 and 4. It is very important for you to make these kind of observations. And all of you, I have not till date seen your collab files. I would like you to share your collab files along with the comments, so that I can understand that you people are understanding. And if you people have any kind of doubts, please do know. Please let me know, because this is a very tricky area to be in. And I have told you everything that I know, but when you are doing or when you are thinking about it, you may get some questions. So it is very important for you to ask them right away. So at this moment, we are done with the most of the visualization, but still we have a little bit of visualization that is left. Now, for those people who don't know about correlation, I'll be saying, I'll be explaining correlation. So correlation, okay, the correlation is a term. Correlation is a term, and the value of the correlation ranges from -1 to +1. Okay, this is the extent that you need to understand. What is this correlation? Now, let's assume some of the things that you need to I some things so that you can understand better. But I still expect that you people know about correlation to some extent. But still, I'll be explaining it. But I am not going to spend a lot of amount of time on this, because I have many things to do, many things for you to understand. So let's just go through it a little bit fast. So there is something which is known as positively correlated data. What is this positively correlated data? Positively correlated data means the if the value, or suppose, let's assume an example so that you can understand it better, because if I start defining the mathematical terms, it will be a little bit of a mess. So just assume one thing. If the square foot of the house increases, the price of the house also increases. So if the square foot of the house also increases, the price also increases. This type of relation are also known as positively correlated data. Now, by any means, by some hypothetical situation, if it happens, if the square foot of the house increases and the price decreases, I repeat, the square foot of the house as increases, the price decreases, then it is known as negatively correlated data. I'm not going very far in this, because I hope that you will know at least this thing, what is a correlation. And I'm just explaining a little bit what is a positively correlated data and what is a negatively correlated data. Another thing that we should be concerned is that is uncorrelated related data. What is that? Well, that is actually, suppose if the price of the house does not correspond to the amount of square feet that we have. If that is the case, then the data is uncorrelated. Positively correlated data is represented by +1, that is the maximum value of positive correlation. Maximum value of negative correlation is -1, and the uncorrelated data is 0. So the correlated data ranges from -1 to +1. So let's get started. So I'm going to make what is known as a correlation matrix. I'm just going to define this thing. So how do you get the correlation of this entire data set? It is very easy. And the things are so easy nowadays. You just we are using the housing data set, right? So we want to have a correlation for all the correlation values, right? So if you are on all the correlation values, we just write .corr. That stands for correlation, and that's all. That's all. We are done. We are done with our correlation. If you look at the correlation matrix, if you look at the correlation matrix, it looks like something like this, but it's too complicated, right? It is so too many numbers, too many points. Oh my god, I cannot understand all these things, right? Okay, let me just pull up only the data that we want. We are only concerned about the one thing, that is median house value. That is the final value that we need to predict. So we need to see all the attributes which are correlated to that particular data, right? So we are only concerned about one attribute, that is the median house value. That is the final attribute that we have to print or predict. So we are only concerned about that particular median house value. So let's just select that particular median house value column. Let us first select it. So median house value, and I am going to, okay, sorry, I don't think I should be using housing gold, because I'm going to use the correlation matrix. We have a correlation matrix, and from that matrix I am going to select this median house value, and I'm going to sort those values. We can use a function known as sort values to sort all these values into ascending or descending order. Here I want the values in descending order. So I would say it takes by default it sorts the value in ascending order. So I have to say, sorry, ascending equals to false. False. Okay, let's see what happens. Oh, we have here. So what is this number that we are looking at? Now look at it. The median house value is 100% correlated to its own value. Okay, that's okay. So we can see that the median house value is very positively correlated with the median income, and it is also negatively correlated with the latitude. If you cannot understand this latitude thing, that is, if we go far north, as we go far north, we get a negative correlation, that as we go north the value decreases. That's all, right? So, and we can see, look at here, total bedrooms and total households. If you look at these both values, you can see it is almost close to zero, almost close to zero, not exactly zero, but almost close to zero. So we can say that these data are almost uncorrelated. These 2 points are almost uncorrelated. So what is the observations that we have to make from this particular result or output? The result that we have to make, that this median income is a very important attribute for our prediction. We have to be very careful about this median income. This is the first observation that you have to make. But to be honest, this as I said, Jay, looking at numbers is boring, right? So let's I am going to show you a modern way that you can do this thing. The same thing. I am going to do the same thing, but in a very modern way. Most of you have not heard about this uh, library known as Seaborn. It is a library that is built on Matplotlib and NumPy, and it is used for advanced visualization. Okay, so we are going to first we have to I am going to use a figure size of 2012. So let me just, sorry, 2010, 20 comma 10. So we have it, and I am going to generate what is known as a heat map. What is this heat map? Let me just tell you one thing. Now if I just draw your attention to this median house value, you can see J look at the longitude thing, longitude value, longitude value, and now look at this longitude value. These are the same values. I have just taken this column. It is nothing great. I have just taken this entire column and sort those entire column and sort them into descending order. That's all I have done. But sometimes you want to look at the whole picture, that what values are correlated to which value. Then you have to do this thing for every value. You have to do this line for every column that exists. But and that is a very gruesome and too much work in that. But I don't want to. And to be honest, I can look at this particular matrix, but to be honest, look at it. No, it's completely filled with float numbers. We cannot make any sense out of it. As I said, our human brain cannot interpret too much numerical data, right? So we are not comfortable with this kind of numerical data. So we need to find another way. So that another way is known as heat map. What it does, you will see right away. Okay, we have it. Now look at it. This is the same exact matrix that we generated up here, but now we have colors. And since we have colors, we can understand it better. Now look at it. First, you have to look at the color bar. You can see that as we go darker, it is negatively correlated. As we go higher, it is positively correlated. Okay, let's look at the longitude. Let me just prove to you that longitude, this is the same graph that we are looking at. This is the same matrix that we are looking at. Look at the longitude and look at the median house value. It is 0.047. Look at longitude and look at median house value. It is 0.047, right? So we have the same matrix here. So let's explore the data a little bit more. So what do we have here? Let me just, since I'm just only I'm mostly concerned with, I'm mostly very obsessed with this particular median house value, right? So I'm going to look at the particular row and find what are the things that are there. So we can understand from here that this median income is very bright, right? Hey, sorry. This median income is too bright. What is happening? Yeah. So this median income is too bright, right? So we can say that this data is very positively correlated. Remember that previously, when we were doing this stuff, we also said J median income is positively correlated, as we saw here. Now we can see this in here. Now we can look at the data a little bit more. We can also find that the total rooms and total bedrooms are very close to zero. It is almost uncorrelated, right? So we are not concerned about these two columns, but we have to be very concerned about this particular median income. So as you go right now, you understand that for predicting the house value, the income is very important. So you should be very um, careful while using or transforming or changing anything about this median income. Okay, so we have made this observation. Then this is the when I just love this beauty. When I look at it, it is beautiful, right? It's a matrix that is colored, and you can generate output from it. When it's heavenly, I guess. When it's magical to me. For me, it's magical. I don't know about you, but it's magical for me. So let's move forward. Okay, let's look at some of the more stuffs that we have here. Now, as I said, Jay, this particular how total rooms and total bedrooms that we are looking forward, these are not very correlated with the data, but we want it to be a little bit correlated, right? So what can we actually do? Can we do anything? Let's think. We have 10 attributes, right? Okay, so what can we do here? Hey, I can actually create another one or two attributes, right? From scratch, right? I just can create 2 3 attributes of my own so that it can be of great help, and it will be our model will be good enough. I mean, it's like teaching your child little over 1 or 2 chapters more so that he has a little more knowledge about the subject, right? There is no harm in that. So let's do it. I'm going to create some new attributes. Since these rooms and bedrooms and populations are not very correlated with the data, I'm going to use only these 3. So let's see. I'm going to make a column, sorry, let me just zoom in, known as room per household. I'm going to use the household column and the room column. What I'm going to do, I'm going to divide them with each other. That's what I'm going to do. So sorry, housing, and this is, let's see what we want. We want rooms, where's rooms? Okay, total rooms divided by housing. Now what do we want? We want households, right? Where is household? Where is household? Households. Yeah, households. Sorry, households. Let's make another one. What can we make here? Let me see. How about bedrooms per room? I'm just picking a random thing. I'm just picking a random uh, random attributes that is coming to my mind. Just pick a random thing. So no, we don't have it. Bedrooms per room, right? Sorry. So we have to do a bedroom divided by rooms, right? So housing total, oh sorry, not total bedroom, total rooms. We have to go for, okay. Why can't I get the, yeah, got it. Total bedrooms and divided by housing and total rooms. Okay, let's create another one that is let's see, we have not used this population, right? So let's use what populations per household. Let's try populations per household, right? Yeah, let's try populations per household. Why not? Just pick randomly. You just pick randomly. Population households. Where is household? Where is household? Okay, let's run this thing. Let's see. So our dataset now contains 3 more extra columns. Let's look at our dataset. Look at the head. Remember the head? Okay, it brings up the first 5 columns. Okay, now we have here rooms per household, rooms per bedrooms per room, population per household. But these are still numbers, right? We don't want to we don't understand numbers again. We don't understand numbers. So let's do the correlation matrix. Okay, so do you want to generate a heat map or should I generate a heat map? Okay, let's generate a heat map. It's more fun that way. Let's see. Let's copy, paste. Don't report it twice, otherwise it will throw you an error. Okay, we are good, I guess. Let's see. Okay, too much information. Okay, now I'm only concerned about this median house value, right? Very important thing that to note that we are only concerned about median house value. This is the final thing that we want to. Okay, we have added 3 more columns, right? uh, Rooms per household. Okay, let me just go a little bit low. Yeah. Hmm. This is good. Okay. Okay, we are only concerned, we have seen everything, but we are now want to concern ourselves with off. What is this thing? Concerned with room per households, this thing, this thing, and this thing. So let's see. We are concerned about median house value, right? This one, this row. So let's see what happens. Okay, rooms per households has 0.5, zooms of bedrooms has -2.6, and okay. Now if you look at it, the total bedrooms, total population households, the rooms per households contains more have a is more correlated, positively correlated with median house value than its parents, the parents from which it is the variable is created. So this is the thing, right? Now you have created an attribute which is more correlated than the already existing attributes. So let me just pull up that copy that particular code from here. Yeah, on this copy, paste. I don't also want that correlation matrix like this one, and sort them in ascending order so that we have a more clear idea that what we are looking at. Okay, look, after the median income, the rooms per household takes the place. So it is much more correlated, right? So we have created a value which is more correlated than the existing ones. Okay, but to be honest, you can think, okay, then we have a new good value, right? We have a good thing. And if you can draw your attention that bedrooms per household also is very negatively correlated, right? But this population per household is not something good that we have created. But so okay, these are things, hit and trial, these are hit and trials and all that we need to make. But to be honest, the way I did here is not the optimum way to do things, because maybe later it will cause problems. Why it will cause problems, we will see that later in our sessions, that why it may cause some of the problems. So now I am not going to use these values. Okay, I'm just going to switch back to the original data set, that is the 10 columns and those rows. So let me just grab the original data set once more, but this time I am going to not consider the final column, that we are going to predict. And what is this final column? Median house value, right? So remember strat trend set. Oh, collab members. Drop. I have said drops column. drop deletes something. So if you want to delete something, then you just need to name it median. Sorry, I want to delete median house value, and it's a column that I want to delete. Then it has to be access, it has to be 1, so it deletes it. And but we need to if we delete it, we are left with the 9 columns, but at the end of the day we need our column, right? We need our column back. Now you may argue that why I'm doing this, because at the end of the day I am going to predict this value, and this I need this thing in my data set, right? Yeah, exactly, you need this thing in your data set. But since these are the values that you don't want to transform or do any kind of transformation on this value, because if you transform this final value, it may cause a wrong output, it may give you a wrong output. That's it is best, so it's better to separate this particular column away, because however concerned or however careful you are, sometimes you may make mistakes. So I'm just cutting this particular a off. So I'm going to create a variable node known as housing.labels and strat trend set, and I'm going to select the median house value. Keep a very close eye that I am not using in place equals to true here. That's why it is not transforming the original data set. It is not transforming this one. It's just giving it a copy, creating a copy without the median house value and storing it into housing. Okay. Similarly, I am just taking the particular column and storing it into housing labels, and I am going to copy. Okay. So fingers crossed. Okay, let's let's look at our data set. Housing.head. Remember, those are the first 5 rows. Perfect. Look, we don't have the housing that sorry, median house value. But if I pull up these housing labels and print it here, look, we have all the values. It is not the name of the column is not labeled here, but it is the median house values. And this is the beauty of machine learning, right? So that's it for today. I'm not going to extend it much further, but I would like you to share your Colab files. I am saving this, and of course all my codings are available in the WhatsApp group. So if you have any questions, you may ask now. And if you feel like later you feel like that you have a question, just drop it in the WhatsApp group. I'll be answering as soon as possible. Okay. So till now, we are done. Till now, we are done with our what do I say? Uh, our visualization part. You remember that? Sorry, the first slide, that our machine learning projects is highly based on 3 particular categories, divided into 3 particular categories, 3 main categories. There are data visualization, data pre-processing, and ML algorithms. Now, in this 4th session, we have completed data visualization. I have showed you every possible way that you can visualize this particular data set. In case of other data sets, there are more other visualizations that you can do. I'm not going to get into that because it will be a very long. I can take only 20 sessions on visualization only. So it's not wise to do that. But we have completed visualization for this data set only. Now, from the next day, we are going to enter data pre-processing. And this is a very crucial step. We have been introduced to data pre-processing. I have given you a little bit of idea that what is data pre-processing. Let me get to that slide. Yeah, data pre-processing and why it is important. I'll be repeating every point that I've made in this pre-processing thing tomorrow from the next session. And we will be starting with our pre-processing. There is data cleaning and all. So that's all for today. and hope you liked the visualization part, and you have generated your own California map, housing map, and that's pretty cool, I guess. So now you can sign off, or if you have any questions, you can ask. I'm going to stop presenting.